Of course, one in less than 111, we're using division, which is fine. But realizing that with a word problem that we'll have to work in, each time you have to make a decision. Do I show my answer as a remainder, as a fraction, or in decimal form, which you should be more and more comfortable with finding. They all equal the same amount, but they look different. Or sometimes it's about rounding up, because in a lot of real-world scenarios, you can't just divide into a part of a whole. You need to round to the nearest whole. For example, in example 1, we've got 100 kids, 3 classrooms. How do I split them up to be as balanced as possible? What am I doing? I'm dividing 3 into 100, right? To get 3 equal groups. And you can fit 33 in 3 times, but you're going to have that one kid left over. So 33 in each room. But what about this kid? You don't want to leave him out. You don't want to kick him out of school. So we need to add him on to just one of the classrooms. You end up with a class of 33 twice, and that kid makes 34 on the last one, so he can be included. It's not perfect, right? There's a remainder. It's as balanced as possible. Okay? As possible. So with that situation, that's how we decided. That's what made sense, even if it's not exact. Example 2, matinee movie tickets cost $8. Jim has 30. How many can he buy? $30, and you can get $8 a piece. You put 8 into 30. It doesn't go in evenly 4 times. It only goes in 3. And 6 over 8 is, no, it's 3/4. So can you buy 3/4 of a movie or a ticket? No. So do we round up or do we round down? Read this again. We're going to round down because if you don't have enough, you don't get the ticket at all. So we only can get the 3 tickets. All right, and they show how you do the labels here too, if that's helpful. But the big thing is to understand, do I round up, do I round down, do I round it all? How do I show it? Okay, in example 3, they're splitting up like I do for field trips. You got kids in cars. How many cars will you need? Like our class, we have 13 kids. And if I said, each car can hold 5 kids, how many cars do I need? That's a pretty normal situation for me. Well, I wouldn't be able to only bring 2 1/3 of a car or something like that. If I'm putting 5 into 13, I can get 2 full cars, and then you've got 2/5 is what it is left over. Well, then I have to ask for 3 parents to bring their cars so that I don't have kids hanging off the top of the car. And that's kind of what they do in example 3. And in example 4, we're cutting a 10-foot board into equal lengths. How long was each of the 4 boards? If they're all going to be equal, it's just one measure. 10 feet board. Sometimes it's nice to, draw out what we're doing here. 10-foot board, 4 equal lengths. How long is each one? Well, then it's 10 divided by 4. 10 goes into 4 twice with the half left over. Now, do I round up? Do I round down? Do I show it as a decimal? With feet, measures, and things, you can use a fraction, and we can measure in parts. You can cut part of a board or part of a foot of a board, so we can leave it in that case. It makes sense. In example 5, you're finding the mean of 3 50-meter freestyle swim times between 37.53, 36 and 9/10, and 36 and 63/100. What's the average? How do we find average? You got to add all those up. Okay? Find the sum of everything and then divide by the number of numbers. Okay, so I see 6, 20, I think, 12, 19, 11. Drop the decimal down. 111.06, and then divide that by what? 2-step problem. There were 3 total numbers. So you put that in. You're going to end up getting a decimal or fraction or whatever you use. What do I do with that? Can I measure in parts of a minute, in hundredths of a second? Yes. So they find that mean, they divide by 3, they get 37 and 2/100ths, and they keep that in seconds. Why don't you do C and D for me, please? Now, how about C and E? C and E. Let's do that.